So greetings, YouTube. Beautiful mind here. So this is the second half of the lecture from day one. Um, okay, let's just hop into it. Oh, let me start my timer. Actually, I'll use the one down now. Okay. So we're continuing. This is like a review chapter. So these first two sections, it should be a review from his previous courses. So this section is section R.5, Nonlinear Functions and Models. So some objectives here are to graph functions and to solve applied problems. We want to manipulate radical expressions and rational exponents. We want to determine the domain of a rational function and graph certain rational functions. And we want to find the equilibrium point given a supply function and a domain function. Okay. So a quadratic function f is going to be given by this equation. F of x equals ax squared plus bx plus c, where a is not equal to 0. The leading coefficient is not 0. So the graph of a quadratic function where a is not 0 is called a parabola. It's always a cup-shaped curve. It opens upward if a is positive and opens downward if a is negative. It has a turning point or vertex at a point with the first coordinate x equals negative b over 2a. The vertical line x equals negative b over 2a serves as the line of symmetry. Okay. So we're asked to graph it. So the way that this text seems like it's graphing is using some of the following techniques for graphing quadratics. First, it kind of starts with the vertex of the quadratic, and so we can use the vertex formula. So the x-coordinate of the vertex, vertex formula. Again, if you have like a formula sheet, this is a good one to add to it. The vertex formula, the x-coordinate of the vertex is x equals negative b over 2a. Move some of this stuff around. That's going to be the x-coordinate of the vertex, right? So in this case, our a is 1, our b is negative 2, and our c is negative 3. Okay? So then this is going to be negative 2 over 2 times 1. So the x-coordinate of the vertex is going to be 1. Then define, and that's our k, h. That's our h. So then to find the k, which is going to be the y-coordinate of the vertex, basically we're going to do f of h. So in this case, it's going to be f of 1. So then that's going to be 1 squared minus 2 times 1 minus 3. Okay. So that's going to be 1 minus 2 minus 3, negative 4. So then the vertex ends up being 1 comma negative 3. So that means our axis of symmetry is going to be x equals 1. And then once you have the vertex, and notice that the leading coefficient is a positive 1, so that means the parabola should open upward. So we have the vertex, we have the axis of symmetry. Whenever we have a point on the left, we're automatically given a point on the right. And then again, the parabola opens up because the leading coefficient is positive. It's that positive 1 that you see circled. And yeah, just whenever you get a point on the left, you automatically get a point on the right. So then I would like make a table. Just choose. You need about 3 points: the vertex, a point on the left, point on the right, and then connect them with a smooth curve. Okay. Did I make a mistake? Did I do a negative 4? Oh, surely did. There it is. Yeah, I don't know why I wrote negative 3. I put negative 4 above, and then when I wrote my vertex, for some reason I put negative 3. But negative 4 is proper. Anyway, we had it. It just didn't. I don't know, for some reason it didn't write the right thing. But yeah, we got all that. So then, starting with the vertex, you just plot a few points on either side. Whenever you get a point on the left, you automatically get a point on the right. So 1 to the left of 1 is 0, and 1 to the right of 1 is 2. Both of those have a y value of negative 3. When you just basically plug them into the function and see what the output is. Okay. And then plot the points when you get something like this. You see the time. Okay. So again, they're using the vertex formula. You see it in the center. The x-coordinate is negative b over 2a. So they're finding the vertex. I'm going to leave those for you. Again, if you have questions, or if you need to see like a dedicated video on something, just let me know. Because some of the stuff I'm going to breeze through. And then if you need me to go back in greater detail, just let me know and I will. There's nothing fancy going on there. I'm going to let that be. Okay. So we have the quadratic formula. So the solutions of any quadratic of this form is going to be given by this is negative b over 2a. There's negative b plus or minus the square root of b squared minus 4ac over 2a. So some of my students showed me an interesting way of remembering that, and I'll show you as I use it. So we're asked to solve this, right? So we can actually solve this using the quadratic formula. Let me do the following. I don't think I need that much space. Let me think. But I want to give myself some space here. I'm going to give myself some space. Let me get rid of that one. Yeah. I like it like this. Yeah, I like paper. I like live streaming this because then I can, when I do my edits and all my manipulations, it doesn't show everything, which is what I needed to do. And like if I did it, anyway, I just like the way I do it. Like, what was that? I'm just knocking all my clothes down. Anyway, okay. So we're asked to solve this. So let me start by getting a copy of the original. We have this 3x squared minus 4x equals 2, right? So we can use the quadratic formula, but before we can use the quadratic formula, we need to put it in standard form. So we need to set it to 0. So I'm going to subtract that 2 from both sides, and we'll get 3x squared minus 4x minus 2 equals 0. And quadratic formula is x is going to be equal to, okay, so the way some of my students taught me, or just showed me how they remember it, which I thought it just was instantly locked into my brain, they do the following. Quadratic formula is the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. You know, it's a little bit non-PC, but to me, it's like the movie Hangover. And so, I don't know, when they showed it to me, it was instantly locked into my brain, and so I've been using it for years. Yeah. Anyway, let's identify our A, B, and C. So in this case, notice after we put it in standard form, our A is 3, our B is negative 4, and our C is negative 2, right? So then let's just plug those into the formula. X is going to be negative B, so negative 4, plus or minus the square root of negative 4 squared, minus 4. Our A is 3, and our C is negative 2. All over 2 times A, which is 3. Okay, let me just go to another page. And I'll make these notes available. I'm still kind of setting everything up. I'll make these available for you all to pull them. Okay, so if we keep going, it's going to be 4 plus or minus the square root. It's going to be 16. Double negative is positive. 6 times 4 is 24 over 6. Let me see, 30, so that's 40, square root of 40 over 6. 4 times 10, okay. So then the square root of 4 is 2, so it's going to be 4 plus or minus 2 times the square root of 10. Everything is divisible by 2, so then we get 2 plus or minus the square root of 10 over 3. And and then you can use your calculator to crunch those numbers. Okay. So in my last video, I did pause at this point because I was like trying to get my calculator, my virtual calculator to work. Let me go paper. I think I actually have it working now. Let me get rid of this extra page as well. Delete. Okay. So then let me see if I can get it to come up now. That looks good. Reload and refresh. Because like my iPad was slowing down, and so Apple's pretty good about repairs and things like that. This thing is first generation iPad or second generation, whatever. It's not the latest one. So I went to them and they were like, "Well, we can just replace it for $100." I was like, "Oh, what was that?" It's just that okay. I'm still knocking stuff off this table. I need to finish cleaning. But they were like, "Yeah, we can replace it for $100." I was like, "Okay, that's not bad." So it's basically a brand new iPad for $100. Just replacing the one we already had. Everything is like fresh. I was like, okay, so I'm having to reinstall like everything. It doesn't matter. Anyway, let me get rid of this. Let me just minimize that, and let me show you this. So long story short, the reason I was kind of pausing, I was trying to get this back operational, so I had to like reinstall some stuff. And anyway, that's neither here nor there. Okay, let's see if that is accurate. Okay, so then I just wanted to crunch these numbers, right? 2 plus or minus root 10 over 3. So this is a TI-83 plus emulator. It's coming from this website. The students at a school, they made a ROM, an emulator. It's chemtech.net, CEMETech.net. And it takes a little bit of finagling. You have to like find a ROM. It took a while. It took me years to find it. Then I found it, and I've been using it for years. It works really well. It does what I needed to do. So I just wanted to find those numbers. So like for instance, I'm gonna do parentheses 2 minus the square root of 10 divided by 3. That's not a 3. Okay. And that was good. And we get this. And then I'm just gonna recall that and then do 2 plus. So we got negative 0.387 and 1.72. And I just want to compare that to what they get. There it is right there. 1.721. Okay. Get rid of that. And let's go review. Put this back to this. Okay. So we got the same thing. And so this is just kind of a repeat of what we just did, basically using the quadratic formula, put it in standard form. Once you find your A, B, and C, you plug it in. Okay. So for my calculations, I do intend on using a TI-83 Plus. With this being a remote class, let me see. There are like you don't have to buy 83 Plus. Like for graphing, you can use things like GeoGebra. Um, that's free online graphing. I think it's free. Yeah, I think GeoGebra is free. There's another one I think so this is I think it's called Desmos. I think that's what it's called. It's a free online graphing, but it allows you to look at these graphs. You don't have to like buy a Texas Instrument, a graphic calculator, but it is a great tool to have. It's nice to have it. Um, what you saw me just use was free. It just takes some effort to get it operational, but it's free. Okay. So then a polynomial function is basically going to be a finite sum of monomials. And a monomial is just going to be a real number times some variable x to a non-negative integer exponent. Yeah. Yeah. Right. So again, a monomial is some real number times a variable x, or times some variable to a non-negative integer exponent. Then a polynomial function is just going to be a finite sum of monomials. That's what this slide is basically saying. Using the same set of axes, graph f of x equals x squared and g of x equals x cubed. And all it did was like they chose several values of x find the corresponding y for f and for g, and then plot the order pairs, right? And so you see x squared in blue, it makes the parabola, and then you see x cubed in red, it makes the cubic function shape, kind of like an f almost. But I feel like you can handle that. That's why I didn't go into these details. So functions given by the quotient or ratio of two polynomials are called rational functions. Let's see the time. Okay, we got about 15 minutes, give or take. So we're asked to graph the reciprocal function 1 over x. So we just show several values of x, find the corresponding y, and plot the points. That's all that we did here. Okay. The reciprocal function kind of makes this what you see here, where let me change this color. So like as we trace it left to right, it goes like this. It approaches this vertical asymptote, and then it picks back up on this side over here in that direction. Okay. So now in the last section, we looked at y varies directly as x. So now we're looking at y varies inversely as x. There is some positive number k such that y equals k over x. So we have some positive constant k divided by a variable x. We also say that y is inversely proportional to x. So certain economists theorize that stock prices are inversely proportional. Okay, I have to speak on this because this is going into stocks, right? So I started this venture on. I finally started like just playing around with stocks to see what I can do. I was successfully able to double my money. It wasn't like a lot, but so far I'm still in the green, so I'm happy about it. And so, and I'm a huge gamer, right? I'm gaming, like so I'm constantly gaming. I'm like on Reddit, and I was searching stocks, and I just never came across this Reddit called Wall Street Vet. I was so bad because I was just on Reddit and I saw some posts and people were like congratulating this guy. He had this image. It was basically he invested, I don't know, something maybe $1,000, something like that. I don't know what it was, but he turned it into like $17 million. I was like, is this real? So I go and check Robinhood, and sure enough, like a couple of days ago, GameStop stock was like, a couple of bucks per share. And then because basically they were trying to stick it to like the hedge fund managers, they were trying to bet against GameStop, saying it was going to short. And like since they had all the power, they were trying to force it to short. And they were trying to make money off of GameStop losing value. So this Reddit group decided that they were just going to do it to spite them, just to troll them. And whoever started it, some people had money invested in GameStop before they did all this, and like just like that, whoever already had stock in there, they became millionaires just off of trolling these guys. But it was to me that was a very powerful experience, because like we as the people, we need to see that like the power is actually in our hands. Like we think that we're so powerless, and we're only powerless because we're not united. Like we don't work together. We're constantly bickering, and like we don't have any loyalty. We don't really work together. We always turning on each other. But if we actually band together and like work in one accord, oh my God, we're like unstoppable. There's nothing you can do. It was like I was like I was so close. And there was a part of me when I first started investing, they were like, you always invest in things you spend money on. But I haven't been to GameStop in like a long time. So it just wasn't on my radar. But I was so close. I almost became a millionaire. I'm gonna keep going though, because I know I'm gonna do it. Anyway, just I had to share that story. But this happened like last week, a couple of days ago. It wasn't that long ago. Anyway, eating up our very precious time. So yeah, we got about like 15 minutes. This is fine. I think we're actually okay. So yeah, and so like the ongoing battle now is like, because if people sell it, then the hedge funds managers make money because they're just going to short and they make money on their way down. So these guys are trying to hold their positions because they just said the whole point was they were trying to stick it to the hedge fund managers because they're always, and it's still there's still like some legal implications too, because what happened when the when this stock started to like skyrocket, brokers like Robinhood like locked it out so that people couldn't make trades. And like So they were directly manipulating the stock. Like they were the hedge fund managers, they'll cater to them, but when the everyday layman person does it, then they won't allow them to do that. That wasn't right. Um, let me see. Yeah, like and so like there are lawsuits going out and against Robinhood and people making like me. It's a whole whirlwind. It's so interesting to me. And it's more so like psychology and like less about numbers. It's really interesting. Anyway, I'm trying to get back to focus. Okay. So certain economics theorize that stock prices are inversely proportional to the price of gold. That is, when the price of gold goes up, the prices of stocks go down, and when the price of gold goes down, the prices of stocks go up. Let's assume that the Dow Jones Industrial Average D, an index of the overall price of stock, is inversely proportional to the price of gold G in dollars per ounce. One day the Dow Jones was 91.77, and the price of gold was 364 per ounce. What will the Dow Jones average be if the price of gold drops to 300? Right? Okay. Before I don't want to pull up the answer. I want to add some paper and work it myself. Let's go paper. Okay. Let me see. Let me get a copy of what I need. It says the Dow Jones is inversely proportional to the price of gold, right? So if we were to capture that, let's see. The Dow Jones, okay. So that would be like what? D equals K over G, right? So then one day the Dow was, and I'm going to clean all this up, 91.77, and gold was $364. What will the Dow if gold drops to 300? Okay, I just wanted those data. Now let me pull it. I want to cut. Cool, that looks better. We can go like this. This will be fine. Actually, let's go here. Mm-hmm. We're going to paste those notes we just took. Okay. So we have that the Dow is inversely proportional to gold. So this is how K is just going to be some constant that we're going to solve for. All right. So then if we plug in what we were given, it says when the Dow was 91.77, the price of gold was 364. Okay. So then we multiply both sides by 364, and that constant. Hey Siri, what's 91.77 times 364? 9,177 times 364 is 3. Sorry, one more time. 9,177 times 364 is 3,340,428. That was weird. She like hesitated and apologized like she was an actual person. That's kind of freaking me out. I ain't gonna lie. It's like, what time is it? It's 1:40 in the morning, and she's up here acting like she's alive. It's kind of creepy to me. Like, I feel like now Siri's like breathing over my neck. Yeah, that feels like it could be something over my shoulder and I wouldn't know. It's so eerie. Anyway, I'm just hoping my dog will notice it and like she'll go crazy and get my attention. I'm just confirming that I wrote this down right. 340, 428. Okay. Okay, so that's our constant variation. So then it says what will be the Dow if the price of gold drops, then the Dow should go up, right? So D is going to be equal to this 3,340,428 divided by 300, right? So I'm just going to use my calculator. I got it off screen. All right. So I want to say that divided by 300. 11,134.76. So the Dow, 11,134. I think that's the money. So notice that it did increase. Let's get rid of this. Like that. Let's go here to paper like this. And let's go view. Oof. Single page. Let's see the time. Okay, so we got a solid 10 minutes in this section. Okay, I think we got the same thing. Okay. So graphing absolute value of x. Absolute value is just going to be the positive distance away from 0. So for instance, when x is -3, absolute value of -3 is 3. Absolute value of -1 is 1, so on and so on. Absolute value is the positive distance the number is away from 0. So then you take those x values, you find the corresponding y's, you plot the points. Absolute value kind of makes this V-shaped graph, right? Then we have the square root function. They decided to graph negative square root, so this is going to be like the bottom half of a sideways parabola. Okay, yeah. So then you can see here, like if they just show several values of x and found the corresponding y. Okay. For any non-zero real number a and any integers n and m. Okay, so these are like exponential properties. So if we multiply two exponentials of the same base, we add the exponents right here. If we divide two exponentials with the same base, we subtract the exponents. If we set a power raised to another power, we multiply those exponents. And a negative exponent is 1 over the exponential. Right? So a negative exponent it causes a fraction to flip. So rewrite each of the following with rational exponents, right? Okay. So for instance, fourth root of x is going to be the same as x to the power of 1 over 4. Right? That's the definition of like the denominator. So this denominator here is the index of a radical and vice versa. The index of the radical is the denominator of the exponent. So then if we have the cube root of r squared, that's going to be r raised to the power of 2 over 3. The square root of x to the 10 is going to be x to the power of 10 over 2, which is going to be x to the power of 5. Okay. Cube root of b to the 5th, 1 over that. This is going to be the same as b to the power of 5 over 3, which is going to be b to the power of negative 5 over 3. Okay. Let's see, how do we do? Okay. Okay, let's work on these. Okay. So for 9a, we have 8 to the power of 5 thirds. All right. This is the same as the cube root of 8 to the power of 5. But the cube root of 8 is 2, so it's going to be 2 to the power of 5, which is what, 32. Okay. Let's do 9b. 81 to the power of 3/4. So this is going to be the same as, now when we do square root, whenever that denominator, the index is even, we have to include plus or minus. It's like whenever you do square root, let me think about it. I'm thinking because we're not introducing, like we're not taking the square root, we don't have to do that. We can just take it as is. we can just take it as is. But normally, like if we introduce like an even denominator or even root, we introduce plus or minus, but we're just going to crunch this number. Let me think about it. So we're going to say the fourth root of 81 to the power of 3. So it's going to be what, 3? 3 to the power of 3, which is 27. It might be plus or minus. Let's just see what kind of result. Okay, so they didn't do it here. Okay. But if we were to introduce an even denominator or even root, then we definitely have to do plus or minus. We got those two numbers, okay? Find the domain. So for even root or square root, remember we cannot take the square root of negative numbers. So that means this x plus 3 has to be non-negative. In other words, x plus 3 has to be greater than or equal to 0. So if we solve this x plus 3 is greater than or equal to 0, we get x is greater than or equal to negative 3. So then that tells us the domain. Let me see my time. Okay. So the graph shows the relationship between price and quantity that consumers will demand at that price. The quantity consumers demand is inversely proportional to the price. Okay. At higher prices, suppliers are willing to supply greater quantities than they are at lower prices. Okay. So the equilibrium point is going to be, the equilibrium point is the price and quantity for which the suppliers are willing to supply and the customers are willing to buy. It is the intersection of the two functions, supply equals to demand, right? So when the supply and demand equal based on the quantity, it's fine. So find the equilibrium point. So basically, set these two functions equal to each other and solve. I'm just gonna, because we're pretty much approaching the 35-minute mark. So we just set them equal to each other and solve. And I think you can handle that. I'm gonna leave that as an exercise. So then once you solve for x, you would take that and plug it into either function, right? Just pick one to plug in to find the y coordinate. Okay. So I can't really think of any. I think I touched on everything that I wanted to there. With these sections from day one, they should be available. I linked them to our Blackboard page, so that's why I haven't given you. I'm still kind of like working out of those kinks, so we'll be sure to get you guys going. You are gonna have to purchase access to Pearson. That's just the way Morehouse has their set up. Once upon a time, these kind of materials were included in your tuition, but that's changed. So, you definitely want to go ahead and purchase access as soon as possible. You should be able to access it through Blackboard. Okay, so again, we'll try to get you set up. We'll try to get everyone set up the first day. All right. On that note, from one beautiful mind to another, enjoy the rest of your day.